Okay, welcome to the worksheet video on section 10.6, odds and expectation. You should be familiar with the following prior to working on this worksheet. Understanding or having an idea what we mean by computing the odds in favor of and against an event. So in favor of and against the event. The odds in favor of an event is the ratio of the number of ways it can occur to the number of ways it cannot occur. The odds against an event is the ratio of the number of ways the event cannot occur to the number of ways the event can occur. So notice that these are reciprocals of one another. Odds in favor, ways it can to ways it can. Odds against, the ways it can't to the ways it can. Next, computing odds from probability and computing probability from odds. In other words, these two concepts are based upon knowing the definition of odds and knowing the definition of probabilities. Remember, probability is the number of ways it can occur divided by the number of ways anything can occur. Okay? Well, odds, it either happens or it doesn't happen. Complements of one another. Keep that in mind. All right. You should be able or have an idea of what expected value is. The expected value of an experiment is the sum of all possible outcomes multiplied to their respective probabilities less any cost involved. For example, if you go to a fair and you're offered to play a game and it costs you $5 to play the game, you know you're going to be putting out $5. Now you have a certain chance of winning different prizes. Well, that's where the outcomes are multiplied by their probabilities. But again, you have to keep in consideration any costs. So moving on. Once again, you should be stopping the video, working problem, and then watching the video, right? So you read the problem. We want to find the odds in favor of getting a red. In favor. So how many ways can you get a red? 3. How many ways can you get something that is not red? 2 blue, 1 green, 3. So 3 over 3, which is 1. Another way of writing this is 1 to 1, or working with colons, 1 to 1. So again, odds are basically ratios, fractions, etc. Find the odds against getting a blue. Against getting a blue. How many ways can you get something that's not blue? 3 red, 1 green, 4. How many ways can you get something that is blue? 2. So that's equal to 2, or 2 to 1. Or another way of writing it, like that. That's supposed to be the word 2. All right. Moving on. Now we're going to compute odds from probability. So again, a bag contains several colored balls. A ball is being selected at random. I'm telling you the probability you get red is 3 over 7. Find the odds in favor of getting a red. Well, by looking at the probability, we can tell there are 3 ways to get red. At least when you simplify the fraction, so you can work with that. 3 ways of getting red. The denominator is how many ways you can't get red. Well, there are 7 total outcomes, 7 total possible outcomes. So we have 3 which are red, so there must be 4 which are not red. So 3 over 4, or 3 to 4. Another question. Suppose the probability of getting blue is 20%. If the probability of getting blue is 20%, then the probability basically is 20 over 100. We want to know the odds against getting blue. Against getting blue. Well, there are 100 possible outcomes, 20 which are blue, so it must be that 80 of them are not blue. The denominator for odds against is how many ways you can get it. 20. So that is 4 over 1, which is 4 to 1. Moving on. Okay, in this problem, we want to compute probabilities from the given odds. We are told that the odds in favor of getting a red are 5 to 8. We want to determine the probability of getting red. Well, probability of getting red is how many ways can you get a red? How many ways can we get red? 5, right? Since this is odds in favor. How many ways can we get anything? Anything here. We're talking probability. Well, there are 5 ways to get red, 8 ways to get something, something not red. So 5 plus 8 is the denominator, and we have 5 over 13. So that's the probability of getting red if the odds are 5 to 8. The next one, stop the video, work it out. We're told the odds against getting green are 3 to 2. We want to know the probability of getting green. Well, the number of ways of getting green is 2 because, again, this is odds against green, so the second number is the number of ways you can get it. Once again, since we're talking about odds, the total number of possible outcomes, you add these two numbers together, and we get 2 over 5. Moving on. Okay, pause the video, try the problem, watch the video. We have an experiment here where we select a ticket from a draw for 100 tickets, and we could win $200 or we could win $5. It cost us $10 to play the game, and we want to determine what do we expect to win, quote, or lose by playing this game here. Well, expected value is the outcomes multiplied by their respective probabilities. You add this up, and then you subtract off the cost of the game, right? So the first thing I know is that I can win $200. So that's an outcome. The probability of winning $200 is 1 out of 100. I could win $5. The probability of winning $5 is 10 out of 100. There are 10 tickets worth $5. All the remaining tickets are worth nothing. So 0 times the remaining tickets, which we really don't have to calculate because we're multiplying by 0, but I'll just show you. Well, there are 89 tickets out of the 100 that win nothing. And then finally, I throw in the cost. The cost is $10 to play the game. So that's a negative to me. I paid them $10. When we add all this up, we get 200 plus 50 plus 0 over 100. So we have 250 over 100 minus the 10, which is 250 minus 10, negative 750. We expect to lose $7.50 by playing this game. Okay? My math here is a little sloppy, but bear with me. You can see what's going on, right? I added all this up, then I subtracted off the cost of the game. It came out to be negative, so we expect to actually lose $7.50. The next question, you're thinking about replacement policy for that new big screen TV you're about to buy. That policy will cost you $200. Now there's a 1% chance that your TV will have to be replaced, and in the case it does, the policy, not they, the policy, will pay you $1,500 towards a new TV. We want to know the expected gain or loss if you purchase the policy. So, what can happen here? The TV is fine, meaning I get nothing from the policy, right? The TV doesn't break, the TV's good, I keep the TV, no need for the replacement policy, so there was no gain from the policy. The probability of that happening is 0.99 because there's a 1% chance that it will have to be replaced. Well, if it gets replaced, the outcome is $1,500. The probability that it does need to be replaced is 0.01. So one outcome is I get nothing. The other outcome is I get $1,500, right? But there's a cost involved. It cost me $200 for the policy. So now I'm going to do the math. 0, okay, 1% of 1,500 is 15 minus the 200, so it's a negative 185. I'm expecting a loss of $185 by purchasing this policy, because once again, there's a very low chance I'll be replacing it. But that is the expected value of the policy, okay? A loss of $185. Okay, next problem. Ivan's playing some sort of carnival game here. You read it. So I'm going to let you read it. You stop the video, and I'm going to get right to the problem. The odds in favor of Ivan winning a large stuffed animal, and its odds in favor is the number of ways he can win a large stuffed animal, which is 1, 2, 3, 4. 4 ways of winning. There are 12 balloons in total, right? I didn't count exactly, but 9. Yep, there's 12. There's 12 in total, but again, the denominator is the number of ways he will not win a large stuffed animal. Well, that is 8. 8 of them are not large stuffed animals. 4 also 4 to 8, which is the same thing as 1/4. I'm sorry, not 1/4, 1/2. So 1 to 2 is another way of expressing it. Find the odds against Ivan winning a small animal. So against would be the number of ways you can win something that is not small. Well, if you go through 1, 2, 3, 4, 5, 6, 7. 7 ways of not winning the small animal. 1, 2, 3, 4, 5 ways of winning a small animal. That does add up to 12, so I think we're right. Can't reduce it, so it's 7/5 or 7 to 5. Okay, moving on. Once again, read the problem, look at it, give it some thought. Christine's playing a game. Okay, there are a deck of cards 1 through 10. She chooses a card and she wins an amount of money equal to the value of the card if it's an odd numbered card. She loses $5 and an even numbered card is drawn. So this one here, she wins whatever is on the face of the card if it's odd. Okay, she loses 5 if it's even. Okay, so she could win $1. 1 out of 10 ways of it happening. She could win 3. 1 out of 10 ways of it happening. She could win 5. 1 out of 10 ways of it happening. She could win 7. 1 out of 10 ways. She could win 9. 1 out of 10 ways. But she could lose $5, and that is 5 out of 10 ways, right? So when you do the math, you're going to get. So if you add that up, it comes out to be 0, meaning you expect to win nothing or gain or lose nothing. What can Christine expect in the long run after playing the game many, many times? Well, she can expect to break even. That's what she can do. If she plays a game only once, she's going to win 1, 3, 5, 7, 9, or lose $5. But this is what this is actually saying. If she kept on playing the game, the average will approach 0. so she can expect to break even. Okay, read the problem. I'm going to get to work on this. So the camera company is selling cameras at a profit of $187. They're offering a guarantee that if the camera breaks, they will replace it. Now, there is a 4% chance it's going to have to be replaced once. So if it breaks once, they're out $4,800. The probability of that happening is 0.04. It could break twice. If it breaks twice, they're out $9,600. The probability of that happening is 0.01. And then it might not break, so they're out nothing, and that's 0.95. Now there is a cost that they make, so they're making $187 on the camera. So this is what they expect to get out of selling these cameras in the long run. So if you do the math here, this is a negative 192. This is a negative 96. Add to that 187. And when you add this up, they're expecting to lose $101 for each camera sold in the long run. Okay? So they are not expecting to make money. They're expecting to lose money. And they're expecting to lose $101. All right, read the problem over, work it out, and compare what you get with what I get. When Ashley plays this game, she could win $1. The probability of winning $1 is 1/6. She could win $2. The probability of winning $2 is 1/6. She could win $3. The probability of winning $3 is 1/6. But she can lose $2.50, and the probability she loses $2.50 is 3/6. So when you do the math, you get a negative 50 cents. So she's expecting to lose 50 cents by playing this game. And that's what's being answered in B. She can expect to lose 50 cents. All right? And I think that's it. So good luck with these problems here. Please let me know if you have any questions. Thank you.